Hello, good day. We are going to have an example of how to solve still differential equations. This time, whenever you have the presence of homogeneous polynomials. Now, in our given illustration, this can't be solved using the separation of variables due to the fact that you always have the presence of the two variables together. Now, like in this case, you will have y times the differential of x, and here you have x times the differential of y together, and that will pose a great problem of separating the variables. Actually, it's gonna be impossible to separate x from y in this case. So therefore, we cannot use the separation of variables. So what method are we going to use? Now observe the coefficients of our differentials. Both actually have coefficients which are of the first order. Now, whenever the coefficients of both differentials are of the same order, then they are said to be homogeneous. So that's going to be our approach. Separation of variables is impossible, but since the coefficients are said to be homogeneous, then you need to try a substitution wherein you're going to change one of the variables into another variable, say v in this case, no? So you may do this with either y or with x, no? That means you may also try substituting to x, x is equal to v times y. Alright, it's very clear that we need to substitute the product vx to y, and since we also have the presence of the differential of y over there, so we need also to take the differential of y. So determining the differential of y will give us this one, because v times x obviously is a product. Knowing them, we can now substitute. It's very clear that this was originally y. So I'm sorry. There, it was corrected already to minus, no? Minus. Alright, sorry. And then here, y now changed to the product vx, and of course the differential of y into this differential, and equal to 0. So as you can see, no more y as one of our variables. Then we just remove all grouping symbols. Alright, our substitution, a result of removing grouping symbols, since you have there as a product, all you have to do is distribute. No? Yan. Then you have the product of a binomial and another binomial. So distributive property, but take note that this was the first. I always write b first, followed by x, then 3x square times the differential of v, that's it, times this one, times that one, equal to 0. Then combine similar terms. There are actually similar terms. Alright, as you can see, I have placed a marking just below the two expressions to mean that they are to be combined because they are similar. So this is the beauty of arranging a product, no? A sequence. And most of the time our convention is to do it alphabetically. And the result is right there. Now, look at all the terms. There is a common factor actually, and I'm referring to x. There. So you may factor that out over there and then transpose to the other side. So 0 over x will still give you 0, isn't it? Alright, so the expression above is a result of factoring out x as a common factor, factoring out and then transpose to the other side. Now, the other side is just equal to 0, so 0 over x is still 0, and that is what is left. So what's the next step? Alright, it's the next step, group according to the differential variable. So you're applying actually the associative property as well as the commutative property of addition. Then factor out, of course, the differential variable. Alright, so the succeeding steps will just follow after you have eliminated or combined similar terms and then factored out common factors and then transposed to the other side and then what shall we say, factor out the differential variable, and of course I have here x being another common factor, and I have written it there. Now, remember, this differential expression should be written last because they are the most complex expression, mathematical expression in our equations over there. Now, and we come up with this, we will separate variables because variables may be separated obviously. So ultimately, we will be dealing with a differential equation wherein the variables were separated, but this is not always the case. No? This is not always the case. After manipulating a differential equation whose, shall we say, coefficients are said to be homogeneous. Now, the left side may be solved already, that is by integrating, and that's logarithm, but the right side over there needs mathematical manipulation. So I'm going to show that in the part 2 of this particular video. So that's all for part 1. Thank you very much for watching.